So before we get started on drawing Bohr Rutherford diagrams, I just wanted to do a recap about subatomic particles. Protons have a positive charge, neutrons have a neutral charge or no charge, and electrons have a negative charge. Protons and neutrons are located inside the nucleus. Electrons are located outside the nucleus in energy levels. The atomic number indicates the number of protons. Also, the number of protons is equal to the number of electrons in a neutral atom. The atomic mass is made of the number of protons plus the number of neutrons inside the nucleus. So the number of neutrons is equal to the atomic mass minus the atomic number. Electrons are arranged in energy shells outside the nucleus. In the first shell, it will hold up to a maximum of 2 electrons. The second shell will hold a maximum of 8 electrons, and the third shell also holds a maximum of 8 electrons. Let's take a look at carbon. Carbon has an atomic number of 6. The atomic number will tell you the number of protons as well as the number of electrons. The atomic mass is 12, which is the number of protons plus the number of neutrons. Our first example is hydrogen. The atomic number is 1. The atomic mass is 1. So again, the atomic number is 1. The atomic mass is also 1. A reminder, the number of protons and electrons is the atomic number. And the number of neutrons is going to be the atomic mass, which is 1, minus the atomic number, which is also 1, to give you 0 neutrons. In the box here, we're going to write the symbol for hydrogen, which is H. Protons and neutrons are going to be placed inside the nucleus. You have 1 proton and 0 neutrons. And then you place the electron in the orbit shell. There's 1 electron, and we'll place it at the top. Let's take a look at oxygen. Oxygen has an atomic number of 8 and an atomic mass of 16. If the atomic number is 8, then we also have 8 protons and 8 electrons. And to find the number of neutrons, we will do the atomic mass minus the atomic number, which gives us 8 neutrons. The symbol for oxygen is O. And we're going to place our protons and our neutrons inside the nucleus. We have to place 8 electrons in the electron orbits. Only 2 electrons are able to fit in the first orbit. Then we need to add the remaining 6 into the second orbit, which can fit a maximum of 8 electrons. We're going to leave equal spaces around the first 4 electrons, and after that we begin to pair the electrons. So we have 2 in the first, 4 in the second at the moment, which is 6. So we'll do 7 and 8 electrons total. Our third example is argon. Argon has an atomic number of 18 and an atomic mass of 40. We're going to have 18 protons, which equals 18 electrons. And then we're going to do 40 minus 18 to give us 22 neutrons. We're going to place our protons and our neutrons inside the nucleus. And then we need to put 18 electrons in the electron orbits. Again, only 2 will fit in the first orbit. We're going to pair them up. And then we're going to overflow into the second orbit, placing 1, 2, 3, 4, pairing them up, 6, 7, 8. We now have a total of 10. In the third orbit, that can also only fit 8. And you can see we are complete. We have 18 protons inside the nucleus and 18 electrons outside. The next example we're going to look at is calcium. It has an atomic number of 20 and atomic mass of 40. Calcium has an atomic number of 20, atomic mass of 40. So we have 20 protons, 20 electrons, 40 minus 20 will give us 20 neutrons. Symbol is Ca. Again, we're going to put 20 protons inside the nucleus, 20 neutrons inside the nucleus, and then we need to place 20 electrons in the orbits. 2 will fit in the first, and another 8 will fit in the second orbit. Which will give us a total of 10, overflowing into the third orbit, plus another 8. Will give us a total of 18 electrons. And then we need to go into the fourth orbit to put 2 more. We're going to look at the first column or group and take a look at lithium. Lithium has an atomic number of 3 and an atomic mass of 7. Lithium is in group 1. It has an atomic number of 3, an atomic mass of 7. It's 3 protons, 3 electrons, and 7 minus 3 equals 4 neutrons. We need to draw a nucleus and put 3 protons and 4 neutrons inside the nucleus. We're going to draw our first electron orbit. And we're going to put 2 electrons in the first shell. We need to place 1 more electron for a total of 3 into the second orbit. So lithium has 1 electron in its outer shell, or 1 valence electron. We've done hydrogen, we've done lithium, and now we're going to try sodium. Sodium has an atomic number of 11 and an atomic mass of 23. It has 11 protons, 11 electrons. 23 minus 11 is 12 neutrons. We need to draw a nucleus. We're going to place our protons and neutrons inside the nucleus. And then I'm going to draw our first electron orbit and place 2 electrons in the first shell. We'll need a second orbit. Remember, 8 can fit in this. We have 2 in the first, plus 8 in the second, leaves us with 10 electrons. So we need to draw 1 more ring. And place 1 more electron in the outer shell. Now I just wanted to point out a couple of patterns that you might notice as we were drawing some of the atoms. As you complete the Bohr diagrams, you may have noticed that all members of a group have the same number of valence electrons. and valence electrons are the electrons that are in the outermost shell. So we drew hydrogen, lithium, and sodium, and they all had one electron in the outer shell. Hydrogen, lithium, and sodium are all in group 1, and you'll notice that they all have one electron in the outermost shell, or they all have one valence electron. Every time you go down a group, you will draw an extra circle or orbit around the nucleus. That means that the number of shells increases as you go down the group. So hydrogen is going to have 1 electron orbit, lithium is going to have 2, sodium is going to have 3, and if we drew potassium, it would have 4, and so on. Hydrogen is in the first row or period, and it only has 1 orbit. Lithium is in the second row, and it has 2 orbits. Sodium is in the third row, and it has 3 orbits. And like I pointed out before, if we look down to potassium, it is in the 4th row or period, and it would have 4 electron orbits.